Alright guys, it's time for our first day of EOC review. Woohoo! Alright, we're looking at day one notes. Day one notes. Today we're going to talk about functions, we're going to talk about domain and range. We will hit on inequalities. Alright, so I'm looking at attributes of lines, right? Linear functions are lines. Linear functions are lines. So y equals x is our parent linear function. That's raised to the first power. We call it a linear function because it makes a line, right? So now looking at this line here, there are some key attributes that we have discussed. We know what an x-intercept, a slope, 0, and y-intercept are, right? So you can see both of these arrows are pointing to this dot right here, which is the x-intercept, which is where the function crosses the x-axis. Alright, now 0 is another name for the x-intercept, right? Both of those lines are pointing to that point right there. Okay, again, the x-intercept is where it crosses the x-axis, meaning the y-intercept is where it crosses the y-axis. Slope is your rate of change. Your rate of change, and it's the equation y2 minus y1 divided by x2 minus x1. Slope is your rate of change. Rate of change. So you're going rise over run. Okay, or I could say the change in y, that triangle is a change in delta, or change in x. Right? How much are we changing on the y-axis divided by how much we're changing on the x-axis? Rise over run, y2 minus y1, change in y's over the change in x. That's your slope. So looking at our first example, it says a delivery truck began its rounds with a full tank of gas. The graph to the left shows how the amount of gas he has varies with the number of hours he drives. What does the y-intercept represent? Now again, the y-intercept, we said, is where it crosses the y-axis. Right? So it crosses the y-axis, which is this vertical axis, at 0 to 100. So what does that represent? Okay, time is at 0, so he hasn't started driving yet, and the fuel is at 200 gallons. So that represents a full tank. So whenever he starts his trip. Second question says, what does the 0 represent? Now, again, 0 is another name for your x-intercept. Your x-intercept is down here at 20, 0. So what does this represent? This represents the time driven, and then when y, which is your fuel, is 0, so an empty tank. Okay, or we could say, I guess that's the end of the trip unless he's going to fill back up. He needs some gas. What does the slope represent? Okay, the slope is how quick he is losing gas, or quick he is burning gas. Right? So the rate at which his gas is being used. So again, at y-intercept, where it crosses the y-axis, 0, or the x-intercept, where it crosses the x-axis, and then the slope is how quick he is burning the gas, not the grass. Alright, looking at number 2, right? Here we have our function. Okay, the y-intercept, again, the y-intercept is where it crosses the y-axis, so it is the point 0, y. Again, x has to be 0 for it to be the y-intercept. Okay, so it would look like, it's at the point about 0, 5.5. Okay, now we have the 0, which is the x-intercept. Same thing. Right here. And that's going to be at x, 0 for y. Okay, so we're going to go over x amount. We're going to go up 0 because it has to be on the x-intercept. Has to be on the x-intercept. Now, once again, the slope is the change in y over the change in x. Okay, change in y over change in x. Or I could say y2 minus y1 over x2 minus x1. Okay, I'm sorry. The 0 looks like it's at about, we'll say 7.5. 0. Now we have our 2 points, negative 2, 7, and 6, 1. So let's label this x1. Let's label this y1. This is x2, y2. So I've got y2, which is 1, minus y1, which is 7, 1 minus 7, over x2, 6, minus x1, which is a negative 2. 1 minus 7, negative 6. 6 minus negative 2, change, as a positive 8. I can reduce that and I get negative 3/4. Okay, slope you will see written as m. Okay, slope, m. So all I'm going to do is I'm going to take this, I'm going to plug this into y equals mx plus b. M is your slope, b is your y-intercept. We know that my y-intercept is at 5.5. We know that my slope is a negative 3/4. So my equation is y equals negative 3/4 m x plus b. Bam. Alright, looking at domain and range now. Okay, we have two types of functions. We have discrete functions and continuous functions. Discrete functions, okay, are not continuous, right? So they don't continue. They have a starting point or a stopping point. Okay, those are called discrete functions. Alright, for a discrete function, we will list either my domain and my range. We'll use brackets. We'll use points here. My continuous functions, we will list as inequalities. We will list as inequalities. Alright, so I'm looking at number 1. I have a table of values. That is a discrete function. I have a list of points. So I'm going to use brackets. My domain is all of my x values. S. My range is all my y values. Right? So looking at my domain, I'm looking at my x's. I'm looking at this column right here. So again, I'm going to list them. I'm going to put a bracket. Starting at negative 3 is my lowest. Negative 2 is the next lowest. 3 and 8. Range is all of my y values. Those are all 6. Okay? Now, we could write that as y equals 6. Same thing. Looking at number 2. Number 2 is also a discrete function. Excuse me. Number 2 is a continuous function, Coach Sapp, you dummy. Okay, number 2 is a continuous function. Why? You see this little arrow right here tells me that it keeps going. Continuous function. I'm going to use an inequality to write that. So my domain is all of my x values. So what I'm going to do is I'm going to scan the graph from left to right, and I'm going to find my starting point on the x-axis. So the lowest x value is right here at negative 2. So my domain starts at negative 2. My domain starts at negative 2. Okay, now it continues, and this arrow tells me that it keeps going all the way to infinity. Right? So all of my x values have to be greater than or equal to -2. Now, why did I put an equal sign here? The reason I put an equal sign right here is because that is a dot. It's not an open circle. If you look at number 4, you see an open circle. That means that it's not touching that point. It's not equal to that point. Here I have a dot that tells me that I'm going to put an equals to sign. Whoopsies. My range is all my y values. So what I'm going to do is I'm going to scan the graph from bottom to top. So I'm finding my lowest point on this graph. And there it is right there at that point right there. So what's the y value at that point? The y value at that point, if I go over to the y-axis, is 0. Now, once again, that arrow tells me that it keeps going. Right? So all of my y's have to be greater than or equal to 0. So again, domain is left to right. Range is bottom to top. Domain's all your x values. Range is all of your y values. Looking at number 3, that's another continuous function. We see arrows. So I'm going to write it as an inequality. This arrow tells me it keeps going to negative infinity. That's what infinity is over here to the negative side. Okay, so my domain goes from negative infinity to positive infinity. Okay, you can see it written like that, or you can see it written like this. All real numbers. That's what that means. My range, again, I'm scanning bottom to top. My range starts right there. That's the lowest point that I see on the graph. So what's the y value at that point? Because again, range is y. The y value at that point is right here at 1. So y has to be greater than or equal to 1. Last one, number 4, is a discrete function. You do not see any arrows. So I know that I'm going to use brackets. So what I'm going to do is I'm going to bracket. I'm starting here at 1, 2, 3, and I end at 4. My range, okay, I start here at 1 and I end at 3. Alright, so we got number 5. Number 5 says a student is taking a test. There are 10 problems on the test. 10 problems on the test, and for each problem the student answers correctly, the student receives 10 points. Sketch the graph of the situation and determine the domain and range. Okay, so there are 10 problems on the test. Okay, 10 problems on the test. So if he gets every problem right, he receives 100. Okay, so if this was 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. If he gets 0 problems right, he's making a 0. If he gets 1 problem right, he's making a 10. 2, he's making 20. 3, a 30. 4, 40. 5, 50. 6, 7, 8, 9, 10. So my graph looks like this. The domain is the number of problems correct. The domain is the number of problems correct. Okay, well, if he can either make 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, or 10 problems correct. He can't get more than 10 problems correct. There's only 10 problems. Now, what can he make? My range is my points that he makes. He can get a 0 if he gets no problems correct. He can get a 10. He can get a 20 if he gets 2 problems correct. A 30 if he gets 3 problems correct. 40, 50, 60, 70, 80, 90, and 100. Alright, let's talk about some inequalities. We're going to solve equations and inequalities. So let's go back over how to solve equations or inequality, because we're going to treat an inequality just like we would an equation. Okay, the first step that I need to do is I need to distribute those numbers. That's what that parentheses means. It means that whole thing is multiplied by 4. So 4 times 2y is 8y. 4 times a negative 1 is a negative 4. That's equals negative 10y. Negative 10 times negative 5 is a positive 50. Now what I want to do is I want to get my variables on the same side, and I want to get my numbers on the same side. Or I guess I should say on the other side. So variables come together, numbers go to the other side. So if it's me, I'm going to move this negative 10, because the way I move something in math is I'm going to do the inverse operation. Well, the inverse of minus 10y is to add 10y. And you're going to do it to both sides. Now, like terms are the same variable, same power. So what you're going to do when you are solving is you're going to combine it with its like term. In this case, y is a like term with y. It's the same variable raised to the same power. It's raised to the power of 1. So we're going to combine those like terms. 8y and 10y gives you 18y. Now, like I said, this negative 4 needs to go to the other side. The way I move something in math is to do the inverse operation. So we're going to add 4 to both sides. So we get equals 50 plus 4 is 54. This went away because I moved it over here. So we're trying to get variables on the same side. We're trying to get numbers on the other side. Okay, so now I have 18y equals 54. That is 18 times a y. 18 times a y. Now, like I said earlier, what we're doing is we're doing the inverse operation. So the inverse operation of times is to divide. 54 divided by 18 is 3. Y equals 3. There's your answer. Looking at number 3, I'm going to do the same thing. I'm going to distribute, which means to multiply 2g minus 4 minus 4. So minus 4 and then minus 4 equals, distribute here, 3g minus 9. Now I have like terms here, so I can go ahead and combine those. So I get 2g minus 8 equals 3g minus 9. Once again, we want variables on one side, we want numbers on the other side. Okay, now I'm going to move this 2g that way. Again, the way I move this is I'm going to do the inverse operation. So right now you have 2g. You have $2 in your pocket. You need to get rid of it, so you need to spend it. So minus 2g. That's going to combine with that because those are like terms. 3g minus 2g gives me g. Again, I want to move this 9 away from that. I want my variables over here. I want my numbers on the other side. So I'm going to add 9. So I get negative 8 plus 9, or 9 minus 8, which is 1. So g equals 1. Looking at number 5, I'm going to distribute here. Okay, so I get a negative 2 times negative 1/3 x. That gives me a positive 2/3 x. I'm going to multiply here also, and I get a plus 4. So you look like that right now. Now, once again, we can combine these. Okay, because those are like terms. Why are they like terms? Because they're the same variable. They don't have a variable on them, raised to the same power. So we're going to do 4/3. And we're going to add 5 to that, which is, let me put it in the calculator, 6.33. Now we want to get the x by itself, right? So we're going to move this 4, so minus 4. So 6.33 minus 4 is 2.33. So we have 2/3 x equals 2.33. How do I get rid of a fraction? What you're going to do is you're going to flip it and multiply. So you're multiplying by 3 halves. I flipped it. This became on the top. This became on the bottom. So you're multiplying by 3 halves on both sides. We get x equals 3.5. Last one, we're looking at an inequality. We're going to treat it the exact same way. So I've got 2m minus, I'm going to distribute this negative 4. So minus 4m minus 12 is greater than, I'm going to distribute this negative 1. So negative 2m minus 10. Once again, we have like terms here. Those are both m raised to the first power. So we can go ahead and combine those right now. So I've got negative 2m minus 12 is greater than negative 2m minus 10. So now let's move the m's to the same side. Let's move the numbers to the other side. So let's do the inverse operation, which would be to add 2m. That goes away. Guess what? Those go away also. Okay, so your variables canceled out. So now I have negative 12 is greater than negative 10. Okay, negative 12 is not greater than negative 10. If you owed somebody $12, you do not have more money than if you owed somebody $10. You owe more money here, so that is less. So this is an incorrect statement. So if my variables cancel out and it is an incorrect statement, it is no solution. If your variables cancel out and it is a correct statement, it is all real numbers. How did my variables cancel out? I had a 2m minus 2m. Those went away. Alright, let's look at our functions. How to determine if it is a function or not. Okay, we determine is it a function or not if my x values do not repeat. If my x values do not repeat. I don't care about the y values. All I care about is the x values. If the x value repeats to a different y value, it is not a function. Now, you see here it says, for a graph, if you have a graph, we're going to use the vertical line test. Okay, if it touches my vertical line more than once, it is not a function. So the first one, you have a graph, right? So if I'm drawing vertical lines, that graph never touches my vertical line more than once. So this is a function. Okay, what that looks like in table form is that my x values cannot repeat to a different y value. Again, I don't care about the y values. All I care about is this x value. I have a 3, a negative 2, a negative 3, and an 8. None of those repeat. So yes, this is a function. If I'm looking at this mapping, I have a negative 5, which is my x value, and it maps to 3. So you have a point at negative 5, 3. You have another point at negative 5, 12. So that x value of negative 5 maps to 3 and it maps to 12. Well, the x values cannot repeat. So this is not a function. If we're looking here, I've got an x value of negative 3, 6, 8, 0, and 6. So my 6 maps to negative 1 and my 6 maps to negative 12. So this is not a function. Now, once again, why is that the case? Okay, if I was to graph these points, I would have a point at 6, negative 1. So let's say it's right there. I would also have a point at 6, negative 12, which is way down here. So if you're doing the vertical line test, guess what? It's going to touch it more than once. That's why it is not a function. So again, if it asks if it's a function or not, the x values cannot repeat. The x values cannot repeat. Let's look at graphs of inequalities. Let's look at graphs of inequalities. We have 4 types of inequality symbols. We have a less than, greater than, less than or equal to, greater than or equal to. Okay, a less than symbol. When you see a less than symbol, this is a dashed line. A greater than symbol is also a dashed line. Why it's dashed is because my points on this line are not included in what we call our solution set. My points on this line are not included in the solution set. That's why it has to be a dashed line, because it's not equal to. If it says equal to, like this little bar down here, then it would be a solid line. Okay, so if you see a line, you draw a line. That's the way I always say it. If you see a line, you draw a line. If you don't, it's a dashed. Looks like this right here. Okay, now if it's less than, I'm going to shade below. If it's greater than, I'm going to shade above. Once again, this is less than or equal to, so less than we shade below. And greater than or equal to, we shade above. Alright, so let's look at our examples. It says write the inequalities that best represent the graphs below. So is the line solid or dotted? We know that it's dashed. So I know I'm either choosing less than or greater than in my inequality. Is it shading above or below? It's shading above, right? Because we are above this line. We know that the y-intercept is right here at 0, 2. We know the slope is going to go up 3 over 1, because this is another point on the graph, right? So it went up 1, 2, 3 over 1. So the slope is positive 3. So we've got y equals mx plus b. But now, once again, it's an inequality, so we're not going to write an equal sign. But for the sake of it, that's m. That's our y-intercept. So y something, I'm going to leave that inequality symbol blank for right now. M, which is the slope, 3, x plus b, which is 2. Now let's fill in our inequality symbol. We know that it's a dashed line and we're shading above. Dashed line, shade above. Holy smokes, Coach Sapp, what are you doing? Above. Greater than. Number 2, we know that it's a solid line. So I'm choosing between these two. It's shaded below. So it's a solid line and it's shaded below. So we know we're using that sign right there. I'm going to go ahead and write it in. Alright, let's find our y-intercept. Our y-intercept is right here. That's at the point 0, negative 1. Our slope is going to go down 1 over 2. So down 1 over 2. So negative 1/2. It's going down. It is a negative slope. So y is less than or equal to negative 1/2 x minus 1. Again, I'm plugging into this right here. So m, slope, negative 1/2 x, b is a negative 1. I want to graph this inequality. I want it in this form, so I need to get y by itself. So I'm going to divide by 2 on both sides. I get y is less than 2x minus 5. So let's graph our y-intercept of negative 5. 2, 3, 4, 5. Bam. Right there. I have a slope of 2, right? That's a positive 2 over 1. So I'm going to go up 2 over 1. Up 2 over 1. Up 2 over 1. Up 2 over 1. Now, I look at my inequality symbol. That is a less than symbol. So if we go back up here, less than tells me it's a dashed line and I'm shading below. So I need to fill this in with a dashed line. And I'm shading below the graph. Number 4, we're going to graph that inequality. I need to move this 6x, so I'm going to subtract 6x on both sides. I've got negative 3y is less than or equal to negative 6x plus 9. I'm going to divide by my coefficient. So I'm dividing each number by negative 3. When you divide by a negative number with an inequality, you must flip your inequality. So right now it's a less than or equal to. I'm making it a greater than or equal to, because I divided by a negative. If you divide or you multiply by a negative, you must flip the inequality. So that's why it became a greater than. Negative 6 divided by negative 3 is a positive 2, and then minus 3. So we'll plot our y-intercept, which is at negative 3. We're going to go up 2 over 1. So m is a positive 2 over 1. So up 2 over 1. Up 2 over 1. Up 2 over 1. Now, let's look at our inequality symbol. It's greater than or equal to. So if you see a line, you draw a line. So I'm going to connect these with a solid line. I'm shading above because it's greater than. So my solution set is up here. What that means, the solution set, means that every point that I'm shading in right now makes that inequality true. Right? So if I was to plug in this point at 0, 0, it would make this inequality a true statement. If I plugged in 0 for x and I plugged in 0 for y, it would be true. Right? Because 0 is greater than or equal to 2 times 0, which is 0, minus 3. Well, 0 is greater than or equal to negative 3. Yes, that's true. That's why that part is part of my solution set. So if you ever want to check yourself, pick a point in your shaded area. It should make your inequality be a true statement. Number 5 says, Keisha is babysitting at $8 per hour to earn money for a car. So far, she has saved $1,300. The car that Keisha wants to buy costs at least $5,440. How much money does Keisha still need to earn to buy the car? Okay, so my y value is 5,440, right? We're trying to get that much money. It costs at least that much. At least that much. So I need to make at least that much. I can make that much, or I can make more. I've got to have at least $5,440 to pay for it. So it can be equal to, or I can make more than that. Okay, so now let's talk about how much she has. She has $1,300. And she earns $8 per hour. Anytime you see that per hour, that's going to be with your variable. So 8x. There's your inequality. She's earning $8 per hour plus what she already has of $1,300. And that has to be how much money she's earning, has to be greater than or equal to how much she has to pay for the car. Last one says a DJ added 20 more songs to his MP3 player, making the total more than 61. How many songs were originally on the player? Okay, so I want to know a DJ added 20 more songs to his MP3 player, making the total more than $61. So here's going to be my total songs. Okay, so the total songs, 61. He added 20 more songs. So we had the original number, X, and added 20 to it. Okay, making his total more than 61. Right? So this is the total, the original, plus 20. And it's going to be more than 61. Okay, so now I want to solve for x, right? I'm going to subtract 20. So we know that x has to be greater than 41, right? So he had at least 41 songs on his original player because it said he had a total more than 61 songs.